The Earth exerts a weight force on all objects. It is a force due to gravity. Weight always points downwards. For example, this is an object sitting on a table. The weight of this object points downwards and is labeled as W. Weight is measured in Newton. It is equal to mg, where m is mass in kilogram, or kg, and g is called gravitational acceleration, or acceleration due to gravity. Its value is 10 meters per second square. In physics, you may learn it as 9.8, but in this syllabus, we'll use 10. For example, if the mass of the object, m is 2 kg, then W is 20 Newton. Sometimes we may see in a question, it says the mass or weight of an object is negligible. This means we can ignore the mass or weight of the object. When two surfaces contact, there may be two contact forces. One is normal contact, or normal reaction force. The other is friction. Normal reaction force is perpendicular to the contact surfaces. For example, this object lies on a table. The two surfaces make contact. The table exerts a normal reaction force R1 to the object. You can think of it as supporting force. The object exerts a normal reaction force R2 to the table. You can think of it as pressure force. The other contact force is friction. Friction is parallel to the contact surface. There are two kinds of friction, static friction and dynamic friction. When the object is at rest, there's static friction. Static friction is against the tendency of moving. For example, this object lies at rest on a slope. If the surface was smooth, the object would slide down the slope. So the tendency of moving is to go down the slope. Therefore, the static friction is in the opposite direction, which points upwards along the slope. The object stays at rest because of this friction. We use Fr to label the friction force. When the object is moving, there's dynamic friction. Dynamic friction is against the moving direction. Now, there's a force F, pulling the object to go up the slope, then there's dynamic friction. It is against the moving direction, so it points downwards along the slope. A string is always light and inextensible in this syllabus. Light means we can ignore the string's mass and weight. Inextensible means the shape of the string will never change. When the string is slack, there's no tension. For example, this object is hanging down from a surface by a string. A hand is holding the object, so that the string is slack. In this case, there's no tension in the string. When the string is taut, there's tension. If the object is released, it's hanging down from the surface and the string is taut. So the string exerts a tension T on the object that points upwards. The two tensions on the same string segment have equal magnitude. For example, two objects are connected by a string and lie on a surface. A force is pulling them to move to the right. The string is taut. The string exerts a tension T on the right object that points left. The string exerts a tension with the same magnitude on the left object that points right. A light and inextensible connecting rod connects a car and a trailer. When the car is accelerating, there's tension in the rod like a string. The rod exerts a tension on the trailer, pulling it forward. And it exerts a tension on the car, pulling it backward. When the driver hits the brake and the car starts to decelerate, due to inertia, the trailer will still go at the same velocity and crash into the rod. If a string was connecting the car and the trailer, the string would be slack and not able to exert any tension. But the rod is rigid and can exert thrusts. When the car decelerates, the rod exerts a thrust on the trailer, pushing it backward. And it exerts a thrust on the car, pushing it forward. The two tensions or thrusts on the rod of equal magnitude. In this class, we learned Weight is exerted on all objects, and it always points downwards. W is mg. When two surfaces contact, there are two contact forces, normal reaction and friction. Normal reaction force is perpendicular to the contact surfaces. When the object is at rest, there may be static friction. When the object is moving, there may be dynamic friction. Static friction is against the object's tendency of moving. Dynamic friction is against the direction of moving. When a string is slack, there's no tension. When a string is taut, there's tension. The two tensions on the same string segment have equal magnitude. A connecting rod that connects a car and a trailer could exert tension or thrust to the car and the trailer. The two tensions or thrusts on the rod of equal magnitude.